This video is going to discuss gray code sequences and how to create them. First question though is, what is a gray code sequence? It is really just a counter with a special encoding that's designed to have only one bit toggle with each count. So if we think of a traditional counter, we could think of the number 0 to 1 to 2 to 3 to 4, etc. And in binary, it would be listed as 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, etc. So what's interesting to see here is one bit changes on the first sequence from 0 to 1, but on the second uh, uh, transition, we have 1 to 2, the least significant bit changes, and the middle bit changes. We see this in a 3-bit counter. What if we wished to create a count sequence where only one bit changed? One bit. Changes between counts. This would be a gray code sequence. There's a very simple algorithm to develop short gray code sequences. Let's start with a single bit, 1-bit sequence. 0, 1. What's nice about a 1-bit gray code sequence is that it's trivial. It's the same as a standard counter. We just toggle 0 to 1 to 0 to 1 to 0 to 1 ad infinitum. And if we count 0, 1, 2, 3 in a standard sequence, it's 0, 1, 0, 1, 0, 1. But in a gray code sequence, we're going to take, first of all, this part, and we're going to mirror it down here. So instead of going 0, 1, 0, 1, we're going to say 0, 1, 1, 0. We've mirrored it around this reflection point. Finally, we list above the reflection zeros for the next significant bit and ones below the reflection point. Notice that with each transition we have one transition. At the reflection point, we have only a transition at the most significant bit, and then we have a transition on the least significant bit. And when we wrap around, we have a transition only on the most significant bit again. So we can actually have a full sequence that wraps around in a cycle. Let's redraw this sequence. 0, 0, 0, 1, 1, 1, 1, 0. So we have a 2-bit gray code sequence here. What if we wish to have a 3-bit gray code sequence? Well, we can take this sequence and mirror it around a mirroring point. So 1, 0, 1, 1, 0, 1, 0, 0. Notice that the 0, 0 is the same at the top and the bottom, so the cycle will be fine. And then it is the same here and here at the reflection point. Let us list zeros for the most significant bit above the reflection point and ones below the reflection point. We know that this sequence is a gray code sequence, and that there are no changes at the reflection point or at the wraparound. This means that there are only changes here at the reflection point, the most significant bit, and up here at the wraparound point. So only one bit changes from one count to the next. So we have now a 3-bit gray code sequence with an 8 count. This is a 4 count. It is possible to develop a 6 count sequence. How do we do that? Let's take the 8 count first. We can go with 0, 0, 0. I'm just copying from here. 0, 0, oops. Let's give ourselves more space. 0, 0, 1, 0, 1, 1, 0, 1, 0, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 0, 0. And what we can do to get a 6 count is we can take these middlemost, these two middling counts here around the reflection point, and we can delete both of them. And then we have these 3 left over above the reflection point and these 3 below. So our count is 0, 0, 0, 0, 0, 1, 0, 1, 1, 1, 1, 1, 1, 0, 1, 1, 0, 0. Notice that we have transition here on the first from the first to the second count, transition here on the next transition here on the next count, transition here on the next count, transition here, transition here, and from one transition to the next, only one bit is changing. We're not having any overlapped boxes. So we know that only one bit changes on each transition. Right, so we have our 6 count. How would we develop an 8 count? Well, you could take the 0, 0, 0, 0, or how would we develop a 16 count rather? That would be a 4-bit. 0, 0, 1, copy the 8-bit. 0, 1, 1, 0, 1, 0, 1, 1, 0, 1, 1, 1, 1, 0, 1, and 1, 0, 0, 0. To develop a 4-bit or 16 count, you could mirror the 8 count. Mirror and add a bit. Add most significant bit. Add MSB, the most significant bit. So we mirror around our mirroring point, and we add zeros above the reflection point or mirroring point and ones below for the most significant bit. And this algorithm can be used to generate a count of any amount. So if we wish to create a grade code count of any even amount, let's define an algorithm for it. Grade code of any even amount n. Such that two to the k minus 1 is less than n, which is less than 2 to the k. Well, notice that log base 2 of n here, ceiling is equal to k. So this will tell us how many times we need to mirror. K mirror steps. For k steps, mirror the sequence. To add MSB. And then, after that, remove two states from center of sequence until number of counts is equal to n. So if you wanted a 10 count grade code sequence, we could start with this 16 count and then remove 2, so it's now 14. Remove 2 more, it's now 12. Remove 2 more, and we have 10. 10 is greater than 8 because of that we are going to need 4 bits to represent a 10 count instead of 3 bits. Therefore, we need to develop the 16 count and then remove 2 counts repeatedly until we get down to a 10 count. So once we've removed these entries, we have a 10 count. 1, 2, 3, 4, 5, 6, 7, whoops. 6, 7, 8, 9, 10. So there's our 10 count.